Welcome to the Deep Dive, the place where we take your source material, your articles, your docs, and really give you that professional shortcut.
Glad to be here.
Today, we're getting into the weeds of Git, but we're focusing on something that is just so foundational for professional code history, for release management. We're talking about Git tags.
Yeah, it's a huge topic. And the easiest way to frame it, I think, is to set it against branches. We've talked about branches before, right? They're like sticky notes. They're movable pointers that kind of follow your work. Tags are the complete opposite. They are the repository's anchors. Permanent. Static.
That anchor analogy is perfect. It just clicks. Because you're not talking about something that's moving with you. You're talking about carving a version number like v1.0, v2.1 into the stone of your code history.
Exactly.
And that's so critical when you have to jump back, say, 6 months ago to see the exact code that was in production for an audit or something.
For a hotfix, yeah. It's essential. The core idea is simple. Marker release. But that simplicity, it hides a lot of important details, especially when you're working on a team.
Okay, so that's our mission for this deep dive. We're going to make sure you walk away knowing the two main types of tags, why one is the professional standard, and this is the big one, how to avoid that classic workflow-breaking mistake when you try to share them with your team.
Let's do it.
All right, let's start with that big difference, because I think a lot of people just hear Git tag and assume, a tag is a tag. But we have lightweight and we have annotated.
We do.
So what's the fundamental, structural difference in how Git even thinks about these two?
It's a massive difference. Honestly, it's the most important thing to get right. A lightweight tag it's just the bare minimum. It's nothing more than a pointer, a simple reference to a commit hash.
So like a bookmark.
A bookmark is a good way to put it. Or like a sticky note. It just points to a page. It lives locally in your .chefstags folder. It's super quick, great for, your own personal checkpoints.
Okay, so it's a quick local marker. But what's the risk? Why is it considered unprofessional if I'm using that for a real release?
Because it has zero context. And that's where the professional standard comes in, the annotated tag.
Okay.
Annotated tags aren't just little files. Git treats them as a full Git object, and that phrase is key.
I want to stop on that full Git object. Break that down for me. If a lightweight tag is just a sticky note, what is an annotated tag?
An annotated tag is more like a notarized certificate. It's stored inside the main Git database, just like a commit is. And because it's a full object, it carries its own metadata, totally separate from the commit it's pointing to.
Okay, metadata. So what are we talking about here? What's on this certificate?
You get the tagger's name and their email. You get the exact timestamp of when the tag was made. And most importantly, you get a dedicated message, a release note.
Oh.
So it's the difference between knowing where the code was and knowing who declared it ready for production, when they did it, and why.
That makes it so much clearer. It's about building an audit trail. That's everything in professional software development, right? Accountability.
Absolutely. And you can take that even further. Annotated tags can be signed with GPG.
Oh, wow.
Yeah, so you can cryptographically prove that the person who claims they created the v5.2 release tag is actually that person. For open source, for secure projects, that's a huge deal.
So it really sounds like lightweight tags are just a dangerous convenience if you ever use them for something public.
Yeah.
The takeaway here has to be annotated tags are the standard. They're non-negotiable for saying this is production version XYZ.
100%. Use lightweight for your own work, maybe before a big refactor. But the second anyone else needs to see or trust that version number, it has to be an annotated tag. It's a note to yourself versus an official publication.
Okay, we've nailed down the why. Let's get into the how, the commands. So if I just want to see what versions are already in my repo, how do I get a list of the existing tags?
The simplest way is just git tag. No arguments. That'll list every single tag in your repository.
But I've seen repos with hundreds of tags. Release candidates, patches, betas, just listing them all is a lot. Is there a way to filter that?
There is, and it's a great little trick. You use the shell flag for your list and then a glob pattern. So for example, if you only want to see version 3 tags, you'd run git tag -lv3.
Ah, that's handy.
Yeah, it really cuts down the noise.
Okay, let's create one. I'm doing some quick work. I want to mark where I started just in case. How do I make that informal lightweight tag?
It's super easy. You just type git tag v1.0-rc1. That's it. It tags whatever commit you're currently on.
Simple enough. But now, the big one, The professional standard. I've merged to main, tests are green, it's go time. I need that fully documented, annotated tag. What are the flags I have to use?
Right, so this one needs two essential flags. You need A for annotated and mhem for the message. So the full command would be something like git tag -a v1.0.0 meter official release of version 1.0.0.
And I'm guessing if you forget the MM for the message, Git probably yells at you or opens your editor.
It opens your editor. It forces you to write that message because for an annotated tag, that context is non-negotiable.
That's a great detail. But here's the real-world problem. You merge, you celebrate, you move on.
Yeah.
And 3 days later, you realize you shipped version 4.1, but completely forgot to tag the commit. It happens.
It happens all the time.
Can you go back in time and tag a commit from the past?
Absolutely. And you need to know how to do this. It's actually really straightforward. You just find the commit hash you need to tag and you stick it on the end of the command.
Oh, really?
Yeah. So it would be git tag AV 4.1.0 nanometer, tagging release 4.1 after the fact, commit hash, and boom, the tag is created right where it should have been.
Now, for the section that I have personally seen cause so much confusion, synchronization. With Git, we're so used to just running git push and trusting that everything, all our commits, just goes up to the server.
And that assumption is the silent killer with tags. This is so important. Tags are not automatically pushed when you run a standard git push.
Okay, wait, say that again. Because this is the single most important thing to hear. You create a perfect, GPG-signed, annotated tag on your machine.
And it stays on your machine.
So your team, your build server, they have no idea it exists.
None. That's the trap. Imagine your CI/CD pipeline is triggered by a new version tag. You do all the work, you create the tag, you run git push, and nothing happens. The build just sits there because the tag never made it to the remote.
I can feel the frustration just thinking about it. So what's the command? How do we explicitly share these things?
If it's just one tag, you can push it individually.
Yep.
Git push origin v6.0. Simple, targeted.
And what if I'm doing a big release and I've made a few tags? A main one, a staging one? Do I have to push them all one by one?
Nope, there's a command for that too. To push all of your local tags at once, which is pretty common, you use the tags flag. So git push origin tags.
Okay, git push origin tags, got it.
That bundles them all up and sends them off. That's usually what you want to do right after a merge.
Now, what about cleanup? Sometimes you create a release candidate tag and then find a bug. You need to get rid of it. How do you delete a tag locally?
Local deletion is easy. It's the delete flag for delete. Tag DCL-RCV 1.1. And it's gone from your machine.
But again, that doesn't touch the remote server. That bad tag is still out there for everyone else to see. How do we kill it on the remote?
This is where the syntax gets a little weird. You have to write this one down. To delete a remote tag, you're basically pushing nothing to it. The command is git push origin rifstacks incorrect -v5.0.
Whoa, that colon. That is not intuitive at all. So you're pushing an empty value to that tag's reference. Is that what's happening?
That is exactly what's happening. The colon tells Git, push nothing to this reference. And when Git sees you pushing nothing to a reference that exists, it interprets that as a delete command. It's weird, but it's critical for keeping your remote history clean.
It really shows that tags are this very intentional, separate layer you have to manage carefully. This has been incredibly thorough. We went from the high-level concept all the way down to that weird colon syntax. Let's synthesize this. What's the essential checklist? The 3 things you have to remember about Git tags.
Okay, number 1, solidify the concept. Branches move, they're fluid. Tags are static. They are permanent anchors in your history.
Number 2, use the right tool. Know the 2 types. Lightweight tags are for you, for local stuff. Annotated tags are for your team, for releases. They're the professional standard with all that crucial metadata.
And finally, number 3, remember the synchronization trap. Tags are not pushed by default. You have to explicitly push them with git push origin tag name or, more commonly, git push origin tags. If you don't, nobody sees them.
So if you connect all that together, why does this matter so much for someone's day-to-day job, for their career?
Because this is the line between an amateur workflow and a professional release pipeline. Proper tagging gives you stable, reproducible points in your history. It's what you roll back to in an emergency. It's what an auditor looks at. It builds trust in your whole process.
That's the goal right there.
Yeah.
So let's leave everyone with one final thought to chew on. We mentioned you can sign annotated tags with GPG. So here's the question. With all the effort we put into secure code reviews, scans, all of it, why might ensuring the identity of the tagger be just as critical as the code itself, especially in something like an open source or a high-security financial project?
thinking about that layer of human trust, that's when you start moving from just coding to real engineering.
The perfect point to end on.
Yeah.
That's all for this deep dive into Git tags. Thanks for joining us.
My pleasure.
We'll see you next time.